So here's your assignment for making predictions with experimental probability. Anytime we're making predictions, as you would have noticed in your notes, we're going to set up a proportion, and proportions are just two ratios. And most of these are going to be part to whole ratios. A lot of them are going to be percents. So let's not forget what a percent is out of, right? Percent is something out of 100. Okay, that's what that percent sign means. So number one, you already know that the answer is 140 times because that was on your notes. Number two, a tennis player hits a serve that cannot be returned 45% of the time. So that's 45 out of 100 times, right? Because percent means 100. That means 45 out of 100. Okay? 45 out of 100 times. Out of 300 serves, how many would you predict that will not be returned? So 45 out of 100 serves, but if she's going to serve it 300 times, it doesn't say she, I guess, it could be a boy, then how many times would you expect for it to be a serve that cannot be returned? We can cross product and divide. Absolutely. You can do 300 times 45 and divide it by 100. You don't have to do that every time if it's very easy to tell how the ratio changed. It's very easy to tell that it went from 100 to 300 by multiplying by 3. So if you multiply the denominator or the ratio on the bottom by 3, the value on the bottom by 3, you do the same thing to the numerator or the value on top. 45 times 3. 45 times 3 is 135. So the question is, how many times would she make the serve that cannot be returned? It's not 135 out of 300. It would be 135 times. Let's go to number 4. Rob notices that 55% of the people leaving the supermarket choose plastic bags instead of paper bags. Out of 600 people, how many can Rob predict will carry plastic bags? So 55% choose plastic instead of paper. So the question is, out of 600, how many would choose plastic? Okay, remember, percent is 55 out of 100. So 55 out of 100 would choose plastic. Okay, so what if 600 people? This is a prediction. 600 people, well, that's 100, so 600 people. And again, it's just like number 2. You can cross multiply and divide if you want to. Absolutely. If that fits best in you and you can just do the same thing over and over, then please do. Or if you see the nice easy way that we went from 100 people to 600 people, like multiplying by 6, you can do that too. Whatever you do to the denominator, do to the numerator, multiply by 6. 55 times 6. I could do that in my head. Some of you can also. You could do 50 times 6 and then 5 times 6 and add those together. But so 6 times 5 is 30. 6 times 5 is 30 plus the 3, 330. 330. So that would be 330 people. Number 6. Excuse me. Frederica can make 65% of her shots. She makes 65% of her shots. If she shoots 75 times, how many shots can she expect to make? So 65% is 65 out of 100. Okay? 65 out of 100. But if she only shoots 75 times, instead of 100 times, then how much can she expect to make? So that's X right there. I don't see how to get from 100 to 75 in a nice, easy way. So I am going to cross product and then divide by the number on the outside. Do 65 times 75. Getting a little messy. $4,875, and then just divide by 100, which I will do down here. I'm going to do it way down here on the bottom right, and then I'll erase it in a second. Divided by 100. So 100 fits into 487 4 times. Divide, multiply, oops, subtract, bring down. 100 fits into 875 8 times. Divide, multiply, subtract. Add a decimal and a couple zeros. Bring down. Bring that other zero down, and you're probably telling it's going to be 48.75. So how many times can Frederica expect to make it? This is silly because you can't make 3/4 of a shot, but it'd be 48.75 times. Okay. Obviously, we would probably round that up since you can't make 3/4 of a shot. So it'd probably be 49, but we can't really estimate that. Okay. Going to the next page. All right, theoretical probability is a little bit different, as you may have noticed in your notes, but not a lot. It's really just what you're trying to do as a ratio on top of the total amount of times it could happen. Okay, so the instructions for 1 through 8, I believe. So we're going to find the probability of number 1. And then we're going to use that to make a prediction in number 2. Okay, so the odd numbers are probably going to be pretty easy. So number 1, Martin flips a fair coin. A fair coin is just a coin that has a heads and a tails. What is the probability that the coin will land on heads? We all know that's 1 out of 2. Okay. So number 2, Martin flips the coin 64 times. How many times can Martin expect the coin to land on heads? Okay, so let's look at this 1 out of 2. I'm going to move that so I can label it. So let's look at this 1 out of 2. The total possible chances is what? Is it 1 or 2? The total is 2. Okay, so we're always going to have the total on the bottom. And the top represents the heads, right? The number, the heads, sorry. What we're looking for. Okay, so that's heads over total. So that's a ratio right there that is labeled. Okay? So we've already got our first part of the proportion. We've got 1 over 2. This is the total. Okay? And this was heads. Okay, so if we flip it 64 times, is 64 the total amount of times we're going to flip it? Yes, it is. So 64 would just go on the bottom. we do not know how many times it would land on heads. Some of you already do because you know there's a half of a chance, right? There's a 50% chance. Some of you already know that's 32, okay? But it gets more difficult. So we're going to cross product and divide by 2. 64 times 1 is 64, and 64 divided by 2 is 32. So there are 32. It's possible that it would land on heads 32 times. Okay. Number 3. A spinner is divided into 5 equal sections labeled 1 to 5. What is the probability that the spinner will land on 3? Well, how many possible chances are there? What's the total amount of chances? There's 5. That's the total. And the number 3, there's only 1, right? So that's a 1 in 5 chance. Okay, so that's the first part of our proportion for number 4. It's going to be the 3 and the total. I should probably put number 3. And we already know that for the first time it's a 1 in 5 chance. If the spinner is spun 60 times, how many times can you expect the spinner to land on 3? 60 times is the total, right? So 60 goes on the bottom. We don't know that. That's what we're finding. So we can cross product and divide, or if you just see a nice easy way to get from 5 to 60, which is times 12, then you can just do the same thing to the top. If you don't like that, what could you do? You could cross product and divide if you wanted to. That divided by that, and you would get the same answer. Okay, so it is 12 times. All right. I guess I will help with numbers. Nah, I'm not going to help. I've already done 4 of them for you. All right, so 9 through 12, we're going to make a prediction based on the theoretical probability. So Gil rolls a number cube 78 times. That's in your notes. You already know that it's 26. All right, 10. Jenna flips 2 pennies 105 times. How many times can she expect both coins to come up heads? So how many times can she expect both coins to come up heads? So this one's a little more difficult. It's multi-step. So she flips 1 coin. What's the probability that it's on heads? It's 1 out of 2, right? She flips the other coin. What's the probability that it lands on heads? It's again 1 out of 2. So the probability of both of those things happening, we've done this before, you just multiply both of them together. That is 1/4. Okay? So 1/4, we have the probability of landing on heads and the total amount of possibilities, which is 1/4. Okay, so we've got heads and total, which is 1/4. All right, but if we flip it 105 times, what's the total amount of times that we're going to flip it? 105. So you put 105 on the bottom, and we are trying to find that right there. I'm going to go ahead and cross product and divide this one. Multiply what you can, divide by the number that's left out. 105 divided by 4. 0, 2, 8, 2, 5. What, 4 times 5? 4 times 6? 24. And we'll probably just stop there. Okay, so what? How many times would you expect it to land on heads? Either 26 or 27, but you can put 26 times. 26 times. Okay? All right, I don't want to do the whole thing for you, so take your time on number 11 and 12. They're obviously very wordy, but you know that there's going to be some stuff you can get rid of. All right? Just for your predictions, just set up a proportion. Remember, the total's always on the bottom. Hope you had a good week back.